Hello, 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 hello. The event is about to start, so please return to your seat. Go on. 出来就是这样，出来走跳。周俊，我换你了，快30分了。你每次都穿好正式。有吗？这是猎装啊。是猎装。对啊。是休闲服。
可以请他们往前坐吗？这样很难看哟。
哎，没坐满啊。
因为现在有大概报不到人，只有不到一半而已。我们说，哎，你们票什么都卖完都没有啊？结果你看看现场，一半的空位，对不对？对啊，大家都迟到了，很好，很好。OK， 工人还有人没有进来的吗？工作人员还有人没有进来的吗？OK 吗？好，哎，那个门什么是不是关一下？门是不是关一下？好。OK， 好，大家好。那我是这次今天活动的总召，我叫邱俊。对，那很高兴今天有这个机会，能够就是代表就是台北 Ethereum Meetup， 然后以及我们很多在Ethereum Foundation 工作的朋友们，那为我们邀请这么多非常厉害的讲者，基本上就是这个领域所有的大牛了。对，那就刚好因为因缘际会，然后来到台湾，然后这次我们才有办法以我们社群的名义发起这样第一场，就是由探讨技术为主的这样一个研讨会。那因为我们是第一次尝试，所以也碍于就是场地、时间、空间的限制，那我们没有办法在短时间内组织就是非常非常丰富的活动。对，那这也是我们第一次就是做一个这样的尝试。那希望我们今天能够做得好，那我们就期待明年这样子。好，那 OK， 哎 ，Speaker please， yeah， you can sit，yeah。好，那我们的议程是预计于40分开始嘛，哈。OK， 对。Yeah， please。Yeah。 好，那在我们 speaker 在 set up 的时候，那好，还有人陆续进来 ，OK。OK， 对，我们现在所有东西都已经 live 了哦，对，所以不要让我乱讲话，到时候被 live 就不好看了，对。It's not working. 刚刚有先试过 OK 嘛，对不对？现在好像接不起来。
Yeah, it was okay when I tested, but now for some reason it says no input.
Maybe just. Oh yeah, it's working, it's working. Yeah. 刚刚好了。
Oh, you have the magic touch.
Yeah.
Oh, good. Oh, maybe
again.
Maybe it's just loose.
Yeah.
Oh, yeah.
Maybe
Okay,
just
okay.
a little bit inside.
It's okay.
Yeah,
That's
okay.
okay.
Cool. Yeah. Okay.
Foundation 的人是我们的人嘛？Foundation
他们基本上现在都还在里面这样子处理事情啊，结果他要出来，所以对，基本上就居然不在现场。
OK。
会收到那个直播啊，直播会收进去。再给你提醒一下。
有现场会中，对。OK， 好，那我们现场活动，那我们就准备要开始了。那开始之前呢，我想要先稍微介绍一下，那我们这是主办方，也就是台北 Ethereum Meetup 的一些介绍。对，因为现场有没有很多会众嘛，对不对？那可能大家是透过粉丝团，可能透过其他任何管道，那知道我们。对，那我们在干嘛呢？那其实我们台北 Ethereum Meetup。我们是一个专注于就是 blockchain technology 的一个社群，那目前就是 focus 在以太坊上面。对，那其实我们每个礼拜，基本上每个月，对，我们都会去邀请不同领域的讲者来为我们就是分享不同的主题。对，那我们主题就包含就是可能就是一些密码学的一些探讨啊。那或者是有关于 Ethereum 底层 Yellow Paper 怎么读之类的，对，那就是完全 focus 在技术为主，对。那同时我们也会就是有很多机会可以邀请到一些国外团队，对，就好比是基金会，或是之前有一些国外也是做类似研究的人，他们就会到台北来，那就是会给我们一些 talk 这样子，对，基本上我们是一个非常活跃，而且就是非常能量的一个社群。那欢迎现场大家各位听众，可以就是尽量参与我们这样子。对，好，那我想接下来我就把这个麦克风交给我们的主持人耀。
Good morning, everybody. Welcome to Taipei. For my dear friends, we are very fortunate to have an awesome lineup of speakers today. So I'll be hosting the event today. My name is Yao. I work for a local blockchain startup called DTCO. And let me introduce our first speaker, Mr. Lane Rettig. And he is the founder, the operator of Crypto NYC. It is a co-working space. And Mr. Riddle graduated from CS Berkeley. He just sold his biomedical software company recently, and is taking huge interest in blockchain space. So he'll tell us today about his thoughts on this project. Let's welcome Mr. Riddle. Oh.
Testing, great. OK， 大家好，我的名字叫何脸，中文名字，我来自纽约。其实我中文讲的太差，所以不好意思，之后我就开始讲英文。That's all the Chinese I'm going to speak today. Yeah, so good morning, guys. Super excited to be here and join you. Thank you so much for inviting us. I think the entire team is really thrilled to be able to discuss some of the exciting stuff happening in Ethereum right now. So my name is Lane. I'm based in New York City. As y'all mentioned, I founded actually the first full-time blockchain co-working space in New York called Crypto NYC, and I've just recently joined the Ethereum research team as well. So thrilled to meet you guys. Brooklyn, love. Cool. So we're talking about design in kind of blockchain, Ethereum, distributed apps today. This is Taiwan, so I assume you guys know what kawaii means, but I'll explain as well. So it helps sometimes to sort of think about and realize how this exciting technology that we use, right? We love blockchain, we love Ethereum, but kind of how this looks right now to the rest of the world. I think it looks something like this. This is sort of what I look like when I try to explain Bitcoin or Ethereum to my friends. You know, it's not approachable. That's sort of what it comes down to. And my question to you and what we'll discuss is how we move from this to this. So this is kawaii, which is the Japanese word for cute. But jokes aside, I mean, I think there really is a lesson in this for us. Kawaii means friendly and approachable, okay? And so it really is a genuine sort of question. How do we begin to build applications and infrastructure that the rest of the world looks at and finds approachable and they get comfortable with easily? So these are the topics we'll cover. We'll do some very brief sort of background, discuss a bit of history and how we got to where we are today. We will talk about mass adoption, what that is and why it matters. We'll discuss a little bit about an app, right? It's a pretty basic question, but what is an app? What has that word meant in the past? What does it mean now? What are distributed apps, decentralized apps? We'll talk about sort of the DApp ecosystem today. We'll talk about some ideas for how we can do a bit better going forward, and then we'll talk about the future. It'll be exciting. I will not go into sort of deep technology in this talk. This is the first talk. I don't know if you've had your coffee yet. We'll keep it sort of high level, and then the following presentations will go much deeper technologically. So, number one, how did we get here? So this happened. How many of you have read the Bitcoin white paper? Tell me you read it. It's a short read. It's awesome. This happened, and then this happened, right? So we're doing kind of a whirlwind tour here. So Bitcoin solved the Byzantine generals problem and gave us an enormous leap forward in, well, let's say kind of record keeping and ledger technology. Actually, sort of the first big advance since double entry bookkeeping. So the first big advance in 400, 500 years. Really massive step forward. And then this thing happened. Thank you, Vitalik. So, Ethereum built on what Bitcoin did and introduced the concept of smart contracts and gave us a Turing-complete virtual machine that we can use to solve much more complicated, interesting problems. This is the next thing that happened. So the Ethereum killer app today is the ICO. This is actually really out of date. There's probably 3 times as many coins by now. And this is sort of where we are right now. This is how I visualize Ethereum today. It's a really beautiful, exciting, powerful machine. There's some pieces missing. There's still some kind of wires sticking out and stuff, but it sort of works, and it does some pretty awesome, exciting things. However, we don't have a ton of users, and we don't have a ton of use cases, applications yet, relatively speaking. There's more every day. So let's pause and talk about mass adoption, right? What is this? Why do we care about mass adoption? This is a adoption S-curve. This is, so yeah, I went to business school, so I feel like I would not have gotten my MBA money's worth if I didn't put up one of these business school slides. But basically, every new technology which is introduced goes through this process, and it just sort of shows you, the slope of this line gives you a sense of how quickly a new technology is growing, how quickly new users are joining, and it's being adopted. Where do you guys think we are today? Sorry? 2.5. Okay, 2.5%. So we're switching from innovators to early adopters. Any other answers? Does anyone think we're in early majority right now? Okay, a couple people. So, I mean, this is subjective, right? I'll let you sort of draw your own conclusions from this, but I think we can all agree that we're very, very early days. However, we're pretty clearly at an inflection point right now, or sort of about to reach an inflection point. Obviously, these are public keys, private keys. These are Bitcoin addresses. So this is okay for us, right? I think most people in this room look at this. It's not especially scary, okay? QR codes, hexadecimal addresses. Okay, we're kind of used to these things, right? However, you have to think, what does this look like to the rest of the world? Something like this. So, I mean, the point I'm trying to make is that we have a long way to go. Okay, we have, again, this really powerful and interesting technology, but it's not something that sort of everyday people are comfortable using. We have a lot of challenges, a lot of design challenges, and private keys, identity management, key management, that's one example. We'll talk about several others as well. What would it take? I asked myself this, actually, as a thought experiment. What would it take to get Ethereum or any of these technologies to a place where my grandmother would feel comfortable using it? Maybe she doesn't even know. It's not my grandmother, no. So this sort of brings us to the question, right? Why do we need mass adoption in the first place? What is wrong? If the 50 people, 100 people in this room, we use Ethereum, we love it, it does cool things, it makes us happy, why do we care? Why do we need anyone else to care about this project? The most obvious answer is network effects, right? These are really powerful and really important. The power and the value, I should say, the value of a network, this is Metcalfe's law, increases as the square of the number of users. In some cases, even faster than that. And there's lots of examples here. More applications create value for people, right? More applications mean existing apps can talk to other apps. More nodes in the network make the system more secure. More people transacting with Ether or any of these currencies makes that sort of more useful as a currency. So this is kind of the obvious answer. But there's another answer which I think is equally important, and that is permissionless innovation. So this is a topic that I would ask everyone to kind of think a little bit about. We've seen this trend play out in other spaces. So government is a good example. right? In history, we had sort of monarchs and a lot of dictators, and we went from that to sort of an aristocracy, and from there to democracy, which is not perfect, but at least we're moving in the direction of decentralization, opening up political power. We've seen the same thing happen with things like knowledge and information. Way back, the church had a monopoly on information. Only priests had access to books, right? And later, sort of everyday people got access to it. And then the gatekeepers, such as the newspapers and the media companies and the companies that control music and movies and things, opened up a lot, thanks to the internet, things like blogging and YouTube. Permissionless innovation is basically the concept that everyone in this room, everyone in the world, can create and invent new things, new ideas, new technologies. You don't need anyone's permission to do it anymore. So this is now finally coming to value and money, thanks to the blockchain. You don't need the permission of the government. You don't need the permission of a bank, a central bank, or anybody to build an Ethereum application. In fact, even this little boy here has every tool that he needs to create not just an application, not just a bank account, but a bank or a digital currency, okay? And little boys and girls all around the world like him now have these tools basically in their pocket. And we're not far away from a world where even a mobile phone can begin enabling some of this. Again, doesn't need anyone's permission to do it. Okay, cool. So let's change gears a little bit here and talk about apps. What is an app? I guess we all use hundreds of apps every day without really thinking about it. Does anybody recognize this? This is before my time, probably most people here. So a long, long, long time ago, we had mainframe computers like this. This is sort of the first era of kind of mass computing. Okay, and from this, very centralized. Okay, so obviously there's an application running on a computer and an operator interacting with it. Then we got these personal computers, still very centralized, right? Still have an application running on this computer. Later we moved into this sort of connected cloud world, which is sort of where we are today. You know, we have been for about the past 10 years. So lots of exciting new things happening here, lots of new technologies. We have mobile, we have the cloud, you know, we have the ability for apps to talk to other apps. But the important thing to recognize about this is that it's still top-down. Okay, it's still sort of this client-server, command and control, top-down, centralized network topology. And this is not all bad, right? It makes some things very efficient. So a lot of the mobile applications that we use every day, you know, Facebook and Line and Twitter and et cetera, choose your favorite app. They're quite good at what they do and at solving problems, but obviously they're not perfect. This is the world that we're moving into. Okay, so now we're getting into sort of this new concept of a decentralized app, which we call a DApp or a DApp. This really, really, really changes everything. So as a software developer, I've been building apps like this for about 20 years. And I'm still trying to understand all the implications of doing it like this. I'll give you a couple examples. These apps work in a peer-to-peer fashion. Okay, and so that is by definition harder, and there's more overhead, it's a bit slower, right? Each node in this network needs a way to find other nodes, connect to those nodes, communicate with them. Really simple concepts like file storage are very tricky here, right? We don't have a centralized server. There's not sort of a simple place we can just throw our data. Basic things like push notifications, right? All of the apps send us little notifications on our phone. We don't really have a way to do that yet in this sort of decentralized app world. And these are the sort of challenges that lead to some of these design questions we're talking about. Another point to make here that's very exciting about this decentralized app world is that it gives us more control over our data, right? So in a world like this, the Facebooks and the Googles and the Ubers sort of own and control our data, whereas in this world, the data is pushed to the edge of the network. So each of these nodes sort of has control over its own data. Let's look at what DApps look like today. So this is a DApp. This is built on a platform called Blockstack. And this particular DApp is a name registration service, so a bit like a decentralized version of DNS. This is, don't worry if you can't read the text, the point is it's a command line application. No big deal if you're a developer, but maybe a bit tough for the average person. My grandmother will not use this. This is a DApp. This one is called Swarm City. This is a decentralized peer-to-peer marketplace for services, so things like ride sharing. So when you log in to this app, you land on this page. It's a wallet, okay? And this is built on Ethereum. It's an ERC20 token. So here's the problem. In order to use this app, first of all, I need Ether. Why? Because I need to pay gas for all my transactions. Okay, fine. I also need another token called, this particular service uses a token called a SWAT token, okay? SWT. So let's review, right? I'm an everyday user. Okay, first I need to figure out, so I sign up for this, I log in, I have an empty wallet. I need to figure out how to turn my fiat money, my US dollars, into Ether, okay? Then I need to figure out how to sell Ether and buy SWAT tokens. There's not many exchanges that sell SWAT tokens. Then I need to figure out that this is a public key. I need to figure out how to transfer both of those tokens into this wallet. You see what I'm getting at here, okay? It's challenging. It's a cool app, it's a cool idea, but it's just not good user experience yet. This is a DApp called Open Bazaar, which is built on Bitcoin, actually. This is one of the most mature, sophisticated DApps today. It's really cool. It's a decentralized market, peer-to-peer market for physical things, mostly, or in this case, digital books. It's a decentralized version of eBay, basically. So I like this one. If you sort of squint and look at it and you kind of ignore the addresses at the bottom and the peer ID, it looks a bit like a normal app. You know, maybe an everyday person would use it. You have a follow button and message button. And when you have to pay, you get this. So again, you know, you can get this far without owning any Bitcoin, but now all of a sudden, okay, a QR code. I guess in Taiwan, you guys are used to QR codes, but they still kind of scare Americans. Let's read this message. It says, altcoins, I'm just reading here, altcoins will be available when Shapeshift updates to segregated witness. What's an altcoin? What's Shapeshift? And what's segregated witness? And why do I care? Again, I think most people in this room are like, oh, okay, no worries. Shapeshift is great. But again, just this is about empathy and about thinking, looking at these products and tools that we're using from the perspective of everyday users. We get a lot of this, too, unfortunately. It's very slow. The data is all decentralized. It's built on IPFS. It's cool, but it's slow. And a rule of thumb in design is if anything takes more than 2 or 3 seconds, users will not wait. So we're not there yet. This is a really cool Twitter sort of clone app built on Ethereum called Leroy, Leroy.io, I think. I'll just read this first message. I don't always spend $5 a day on Ethereum gas, but when I do, it's to play with a slow Twitter clone with no ads and cool people to follow. Pretty cool, but pretty slow still. And when I signed up, you sort of send a transaction, you pay gas, and then you have to wait. So currently we're at roughly 12-second block times in Ethereum. So logging in takes, signing up I should say, takes 12 seconds, 15 seconds, 20 seconds. Not a great user experience, but a cool idea. There are some great DApps, by the way. I don't want to suggest that everything is sort of difficult right now. So this is one of my favorites. This is imToken. This is an Ethereum ERC20 wallet app for a mobile phone. And you guys will hear from Ben this afternoon, the CEO of this company. Really, really cool project. This is the Ethereum name service, ENS. So these are beginning to solve some of the problems I was describing. So I think imToken helps a lot with the kind of managing ERC20 tokens. This helps a lot with those scary looking addresses, right? You can send Ether to me at lanerettig.eth. You don't need my public key. This is another great example. This is Uport. Uport is a consensus project, and it's working on things like identity and key management. So this also, it's not so scary, right? You try to sort of log into an app that needs to know who you are, they need your public key, or you want to sign a transaction, and actually you get this very friendly looking pop-up. You can also authenticate with a thumbprint on the phone. So, you know, we're beginning to solve some of these problems. All right, there's still things we can do better, so let's talk about those things. Everything I've described so far, does this sound familiar? Have we been here before? Personally, I find it very helpful to look at historical examples. When looking at new technologies, history sort of repeats itself. You hear a lot of people say that the blockchain, Ethereum, is sort of where the web was in 1995 or 1997. I think we're sort of here. Anyone recognize this computer? I'll be very impressed if someone recognizes it. So this is the Altair. The Altair was released in 1975, and it was the first successful personal computer. The first one that sold, I don't know, 10, 20,000 units, something like that. 1975, okay? So when I look at Ethereum today, I feel that we are sort of where personal computing was in 1975. This computer shipped in a box, unassembled. Okay, so you had to take all of these boards and put them together from nothing, right? And you'll notice there's no keyboard, there's no monitor. You know, this is, and people loved it. You know, this is sort of a machine created by nerds for nerds, right? Which I think is sort of where we are with Ethereum right now. I'm going to read one more quote about this. So, the Altair was relatively difficult to use. The machine contained no operating system, so starting it up required a machine language program to be entered by hand via the front panel switches, one switch at a time. The program was actually a driver for an attached paper tape reader, which was used to read in a real program. So you had to actually sort of put machine code in the front of this machine. It was terrible. And you all know what happened next. 2 years later, 2 years, 1977. So in retrospect, right, looking at this today, this is obvious. This is a computer. Computers haven't changed that much since then. We have keyboards, we have a mouse, we have, you know, a UI. But look at this, and like the minds, the people who looked at this and imagined that it could be better and more useful. So again, we need help going from this to this. So what's the Ethereum version of this? Some challenges that users have today. Let's go through some of these. So key management, identity, we talked about this. Very difficult right now. Scalability. Apps, you know, small, simple, smart contracts work well, but when you try to scale them right now, we have a lot of challenges. We're limited in transactions per second. Payments, token management, we talked about this, very complicated. Speed, we talked about this. Apps are not as reactive or responsive as they could be. And then I want to reiterate, UX. We need better user experience. I want to mention as well, as a developer, I think that DX means developer experience, is important here as well. Basically, simple things that we take for granted when we're building web applications or mobile applications, these primitives, things like file storage, compute power, messaging, we don't really have best practices for these yet for DApps. And I think that if we have better developer experience, that will lead to better user experience. We need something like an AWS. I'm not saying it has to be Amazon. I'm not saying it's a single platform, but it's helpful to think in terms of these primitives and what these best practices should look like for DApps. It's very new. So these are a lot of opportunities to build interesting things here right now. I think we can do better. So I'm going to leave you with 3 pieces of advice, 3 thoughts from design thinking. As developers, as engineers, it's really helpful sometimes to look at some of these lessons that are considered sort of design 101, best practice. The first thing is, I think we need to solve real-world problems with these technologies. As engineers, it's very common for us to sort of work on problems because we think they're interesting or fun or exciting. You know, how cool would it be if we had this world computer and we could have these smart contracts? I mean, it's awesome, right? It's really exciting. But we need to sometimes take a step back and ask which real-world problems these tools are solving. And I think Ethereum can help solve a lot of real-world problems, but we haven't quite gotten there yet. Next, hide the complexity. So this is, again, I'm very inspired by a lot of Apple products when I think about this. You know, I run Apple OS X on this computer, and all the complexity is there under the hood. If I want to open the terminal and edit, you know, system configuration files and do low-level stuff, it's there, but it's hidden, sort of, in an elegant way. And so the question I ask is sort of, how do we begin hiding some of this complexity, like things like identity and key management, to make the system more accessible to everyday users? And finally, be user-centric. So, you know, again, rather than prioritizing the developer, the technology, it's really, really helpful to think from the perspective of the user. This is about empathy. I think empathy is a very important tool as a product designer, as an engineer, right? What sort of challenges are our users facing, and how do we help design around them? If you can't tell, this is like a better umbrella. It's pretty cool. And it's attached to a bike. All right, so finally, I just want to leave you with a few questions here to think about. And this is intended to be kind of the beginning of a conversation, of a longer conversation. I personally would love to kind of continue the conversation with you guys. I know I speak for a lot of the members of the Ethereum team as well when I say that we are working on a lot of these challenges and we need help, we need input. A lot of this sort of conversation is happening publicly online. We can talk about resources. So first of all, scalability. This is a huge theme right now. This is the #1 focus of the Ethereum team and of many other projects. We are aware that we need to improve, and we're working on it. You'll hear a presentation today on Raiden, which is one sort of project working on scalability for Ethereum. There's actually 4 or 5 or 6 different initiatives. So we have things like sharding and stateless clients, you know, all sorts of different projects, Casper obviously being a big one that will make the system more scalable. Identity private key management, okay, we've spoken about this a couple times. Just some interesting questions to ask, right? We're used to this world where identity is tied to things like email addresses or phone numbers. You know, I carry a passport or a driver's license. These technologies are a little out of date. And so what does it mean in a blockchain world, in a decentralized app world, right? What does identity mean? How do we, I mean, private keys are not going away, right? Sort of the asymmetric key pair cryptography is a fundamental piece of the blockchain. It's not going away, but how do we build layers of identity on top of that? Another great question is what needs to be on-chain and what does not, right? You'd be surprised, actually. You can accomplish quite a lot without publishing every little piece of data, every message, every transaction onto the blockchain. And as demand increases, the cost of publishing on-chain is going to become more expensive. I mean, it will, hopefully the costs will come down as well as we bring new technologies online. But this is a great area of research. It's an open question, right? How much can you do without sort of publishing things on-chain? You can actually do quite a bit with exciting layer 2 technologies like state channels, things like Plasma and Raiden and Lightning in the Bitcoin world, and even signatures. Okay, signatures are not a new technology, right? These have been around since the 70s, but actually you can do quite a bit with signatures, but without publishing everything on the blockchain. Another great open sort of research question is things like time to finality. How important is finality? You know, in the world we live in the proof of work world we live in today, we have sort of probabilistic finality, but in Ethereum we're moving towards a deterministic finality. How important is it? How long does it take in order to achieve certain things? And architecture. So just a high-level question, right? When I, as a developer, sit down to create a mobile application or a web application, I have these certain frameworks in my mind. I know what you know, a view is, an MVC, right? I have a model and a view and a controller. I have a client and a server. I have JavaScript frameworks. I have things like React and Angular that are very powerful. We don't have any of this today for dApps. We really need help creating best practice. And so again, really interesting active area here where we can use help. 谢谢大家. Thank you.
Thank you, Lang. So our next speaker, before I introduce the next speaker, we will have a centralized Q&A section at the end of the day. So if you get any questions, feel free to ask. I guess you can ask Lane in the intermission break. But we are going to have a centralized Q&A sections at the end of the day. Our next speaker, Mr. Karl Floersch. Karl, is he here? Okay. Please. During his time, his setting up his gear, I'll give a brief introduction to Karl. So Karl used to work in Consensus as a software engineer. He used to work in music-related blockchain project, and he now joined Ethereum Foundation. He's very interested in crypto economics, which is, I would say, very interesting. For me, at least, a very interesting topic for me. And he developed a lot of smart contracts. So if you get questions, I think he's going to be glad to tell you more about that. So let's welcome Karl.
All right, great. Hello, everyone. How's it going? So today we're going to, this is going to be an interactive kind of learning session. Does everyone have their laptops? Oh my gosh, this is a real predicament. I was told people would have their laptops. Do they? Who is ready to code right now? Okay, we got 2 people. Oh my gosh. Well, hopefully, okay, actually, I do see some laptops. Okay, so I'm gonna assume that everyone's able to code. So, first, there aren't that many requirements. Actually, we're going to install MetaMask. This is going to be like an overview of like Solidity and contract development, and also kind of interactive. So if you have any questions, please feel free to ask. And so. The beginning is we're starting out. I have this tutorial, Learning Solidity Part 1, and it's on karl.tech, and it'll get you started with kind of getting your Ethereum environment set up. And so the key is there's this software called MetaMask, which is basically it allows you to like interact with Ethereum nodes on your device without having to install a full node. So the way that it works, so MetaMask is this nice little plugin, and you can see right here, it allows you, let's see if this is big enough. Here we go. So this is like a wallet, and it's actually super easy to install. The way it actually works is we have on our computer, we're basically signing, we have a private key, and then we're signing and sending transactions and interacting with an Ethereum node, often in Fura's servers. So essentially, there's some servers out there, and we're just like sending transactions and pulling data. So were people aware that this was going to be interactive? This is a good question. Who wasn't aware, or who was aware? Okay, so damn, I actually asked both questions, so I didn't really get any information from that. Who was aware that this would be interactive? Oh man, okay. Well, that's okay. So first, what we want to do is we want to install MetaMask. So if we go to right here, we can go to karl.tech. This is your, and please feel free to follow along. If you can't follow along, that's okay too. So download here, and whoops, we want to, let me quickly uninstall it. So we're going to add the extension, and we will begin the setup process. And so this is all detailed in the Part 1 Learning Solidity. And so we've got this like nice little, license agreement that you have to scroll through. Is this big enough? Maybe I can make it a little bigger. I don't know. I don't think I can make the MetaMask thing bigger. That's okay. Cool. So now we're going to create a password. So this is just going to encrypt our seed. So I'm going to do a very secure password. AD. Let me see. It's hard typing. Okay, that was ADSF 4 times. So if I forget. Great. So this is our seed, right? This is what our private key. We can use this to sign transactions, and we don't want anyone to ever know this. So all of you people, you're going to be able to steal my money. So that's great. So we have this new account. Great. And here, this allows us to switch between the Ethereum mainnet, the Ropsten testnet, and Kovan, a bunch of different testnets. So the difference between these networks, basically, clearly main Ethereum is where you can buy ETH and spend a whole lot of money. But all of these testnets allow us to play with fake money. They have fewer security guarantees, but they have all the same code, right? They're still running normal Ethereum networks. So we're going to be working on the Rinkeby testnet. Now, what we can do is we need to get some ETH. Great. So to get some ETH, Karl happens to be a wealthy Ropsten, or not Ropsten, but a testnet ETH holder, and I have 50 ETH. And so what we can do is I've actually posted a link. I've posted a link which I will pop up right here. And this, if you need some testnet ETH, please just go through the same process, install MetaMask, and then copy your QR code and post it on this fun faucet.markdown thing. So the actual link here, you can find it in Learning Solidity Part 1. Let me see. In the comments section of Learning Solidity Part 1, MetaMask. Let's see. Bit. BIT. Oh man, actually I have it right here. This is what I was going to do. So if you unfortunately it wasn't a more readable URL, but it's at least pretty short. So if you copy this in, you'll be able to get to the get some ETH. So what I'm going to do is I'm going to go here, copy my Ethereum address, and post it like I should. And then I, send myself some ETH. So this is the way that you send ETH, right? It's super simple. You just click that send, put in an amount like 1 ETH, and click next. Now there's one thing here that maybe is good to note. Maybe a little small. Wonder if I can pop it out. Oh well. So it's a little bit hard to see, but you can see that there's this thing called a gas price and a gas limit. So basically, the gas is a unit in Ethereum, and we can pay different amounts for that gas. So essentially, one computational step, maybe an addition, is 1 gas, right? But you can pay a different amount of ETH for each unit of gas. So every time you execute a smart contract, it's going to cost 50 gas, 100 gas, and then we can pay ranging from 20 GWay to an ETH per gas. I mean, clearly that would be way too much. Or we can even pay 0 and just hope that someone accepts our transaction even though we're not going to pay them anything. So I'm going to submit this, and I'm going to use 24 GWay, even though that's kind of high, at least on the mainnet. There we go. So sending the transaction. Now, once you've sent a transaction, you can see it open up in the Etherscan. Etherscan is super useful. They have, and you can notice that this is the Rinkeby testnet, right? You've got sending 1 ETH, and it will eventually pop up. Great. So this is kind of just a little MetaMask. And so once you have MetaMask installed, then we can kind of get to the fun stuff, which is actually smart contract programming. So with Ethereum, the thing that makes it very special is you are able to write these smart contracts, and you trust that they are executed properly, right? You know that the guarantees of Ethereum basically allow us to say, okay, all this code is going to execute exactly as defined. And we can even verify, so our contract went through, we can even look at some of the smart contracts that other people have written, right? So if we go on Etherscan, then we can find some, verified contracts, like similar contracts, or let's see, boom, boom. All of these token contracts, we can all like verify them on Etherscan. So here's a multi-send, and so we're going to use this. If only more people had their addresses, we would be using this multi-send, which allows us to just like basically loop through a bunch of different addresses and send to each one. So this is a contract, basically similar to like a class in Java. It's just like familiar syntax. And this is Solidity, by the way. There's also a programming language called Viper, and that's being developed by Ethereum, by Vitalik and David Knott, who's a cool developer. So this is the constructor. It allows us to, basically it's setting an owner. So one thing that's really important to note is that with all these contracts, it's a shared environment, right? So you can kind of think of Ethereum as a like one shared computer, and each one of these contracts is just like a class in this like massive process. And so you need to make sure that your permissions are correct, right? So we're just doing super simple permissions where we're saying, okay, the person who deploys the smart contract is in fact the message sender. And so message sender, this is actually this is just like a special constant which represents the person who's sending a transaction. And so here we go. It's pretty simple. We've got this. What we want to do is we want to first send money to this smart contract, and then we can, if we are the owner, withdraw that money. And if we want to, we can send 0.5 ETH, just like hard-coded, to all of these addresses. So basically, it allows us to, multi-send. And so this is how you would, send to a lot of accounts, and this is how a lot of like the airdrops, for instance, work. They just use this kind of smart contract. So that's a pretty simple smart contract. In the part 1 of learning Solidity, there's a like even simpler smart contract. It's just like Hello World, which you can go through. And write our first contract, and it takes you through all of the steps that we just went through. But for part 2, we've got some an even more fun, which is kind of starting to see the use of Ethereum. So we've got a commit reveal voting scheme. So there's a number of different kind of categories of smart contracts. Maybe there's like governance. There's these like economic mechanisms. They all kind of it's a little bit of a blurry line, but this is more in the lines of governance. And so what is a commit reveal? So a commit reveal, it may be solving a problem that you didn't even realize the blockchain had. So if we were to implement naive voting, right, what we would do is maybe we write a smart contract that says, okay, we have like a vote method, and you just call this vote method, and you say, okay, I want to vote for a pineapple instead of an apple. And the issue is that everything on Ethereum is going to be public. So everyone is going to be able to open up their block explorer and see, oh, well, some person A just sent a transaction, and that they voted for apple or they voted for pear. So what happens is you can have this kind of like effect where everyone starts piling in on a particular vote. So what do? We want to actually commit reveal. So we want to hide what the vote is until a certain period, and then finally reveal it. So here we go. This is our kind of real world example of what a commit reveal might look like. So first, we have this commit phase where we say, okay, I'm going to write my vote. I'm going to put it in a safe, and then I'm going to give you the safe. Like give the safe to the public, right? So there, I'm committing to my vote. And then, sometime later, I'm going to reveal my vote. And so that means I'm going to take my key, give it to the public, and they'll open it, and they'll verify the actual vote. So this allows us to have this thing where we're distributing our transaction in public, but we're not actually going to be, no one's going to know what it is until we actually reveal it. So in reality, what we're going to do is we're going to use hash functions. So this is, it's amazing what you can do with simple hash functions and signatures. So here's what we're going to do. We're going to take our vote. We're going to put it through a hash function, and we'll get some kind of output. And the output is going to look nothing like the actual vote. And so I can actually show you right here. So if you go into right here, there is generating hashes. So this is just an auto-generating hash thing. So essentially, the property of hash functions is that one input is always going to map to one output, and that output is not going to have this clear mapping back to the input. So you can see, right, we're gonna, like, I'll write Karl, and then I will change, right, it generates this kind of like seemingly random string, and then I'll just change it from a K to a C, the worst name ever, and boom, now we have a completely different string. And if I removed one letter, completely different, right? So there's no information that we're actually revealing by giving up the hash. So once we have the hash, we distribute it. The public has our hash, and then we reveal it. So we take our actual vote, we send the vote and the hash to the public, and we say, okay, the public can say, does this vote actually match up with the hash? So what this actually achieves is this says, okay, we're going to commit to something, and then we are not going to be able to change it until we reveal it, right? So here we go. We're going to set up our smart contract. So Browser Solidity is this really nice tool. We've already kind of looked at it before. It's Remix. It's developed by the Foundation, and it allows us to really easily write these smart contracts. Especially when you have MetaMask, it actually makes it super easy to deploy things to the mainnet, because you can just like switch your network from the testnet to the mainnet. So if we click on here, we will get our commit reveal. So let's make sure that this is big enough. Great. And we have a lot of warnings. All right. So here we go. So injected Web3. So these are our three options, right? Injected Web3 is the way that MetaMask actually works. Right, so the way that we interact with Ethereum in our browser is there's this special JavaScript object called the Web3 object. And the Web3 object basically acts as an interface for sending transactions and pulling data from the blockchain, right? And so it basically, it's just like a really simple library. You can actually open it up if you have MetaMask installed. You can open up any page that you go on, and you just type in Web3, and you can like kind of inspect what the actual object is, right? You have all of these different things like web3.eth, and so it's actually on every page. And so what MetaMask does in the background is it actually just fills up a Web3 object with good defaults that allows you to talk to Infura. So instead of doing injected Web3 though, we're going to just do the JavaScript VM. So this means we can like test it locally. So what we'll do is we will create this vote. So if we look at the commit reveal election, we can see that there are three constructor parameters. We've got the commit reveal phase, choice 1, and choice 2. So our let's make our length 200 seconds, maybe 120. 120 seconds, and let's say apple and pear. Oh man, hard to type. Great. Boom, boom. So cool. We just created a smart contract on our local VM. So it's not actually interacting with the Infura network, but we can. So now what we're going to do, the time is ticking. So the way that this smart contract works is it says, okay, we're going to calculate a commit phase end time. And that's going to be now, which is just a constant built into every smart contract, gives you the current time, plus this commit phase length, times 1 second. So we're going to now, let's actually vote. So the way that we vote, we need to commit to our vote. And so the structure of our commits and reveals is going to be, we're going to either use 1 or 2, right? So this is option 1, this is option 2. But we don't want to give away what our vote is. So if we just committed to this hash, right, it would be pretty easy for people to crack what our actual vote is. So what we want to do is we want to do something like 1, and then we give it some password, right, some super secure password. Password 123. And so now we have this commit, and we can go here, and we commit it. So now there's a weird thing with browser solidity that you have to be aware of. If you want to put in hex, you have to just do this 0x beforehand. That kind of tells the browser solidity that it's actually hex. So great. So we just committed a vote, and let's commit another vote. So let's change this 1 to 2. And copy this. Hopefully I'm still within the time frame of, all right. Boom. Let's see. Did it work? So now we can check how many votes cast. So we cast 2 votes, aka we committed to 2 votes. So we just kind of wait a little bit of time and let the commit phase end. And so you can actually see, by the way, this is just like a log of all the things that have happened with all of our different choices. For instance, we can it's like emitting these logs. So now let's reveal some votes. So the way that we reveal votes, right, back to our kind of diagram is, back to our diagram, we want to send them the actual vote itself and the hash so that it can verify it. So if you look here in the actual commit vote, the reveal vote function, you can see that what we're doing is we're basically saying, first, let's verify that the commit is valid. And that means that, like, basically we have it. And then we're going to do the most important part, which is we say, OK, here's the vote commit. Does it match the hash of the vote? Right? So this checks to see whether or not the actual vote was manipulated or was there to begin with. So we're going to now we'll type in our actual vote, and let's see, it's 1, and copy that, drop it here, and then boom, boom. Requiring some ninja typing, one-handed typing. OK, so reveal vote. Boom. So now we have revealed votes, so we can actually check. OK, here's choice 1 is apple, and choice 2 is pear. But let's see how many votes we have for choice 1. Boom, we have 1 vote. So our vote actually went through. And you'll notice that if I changed this from instead of 1 to, let's say, password 123 to password 12, and we tried to reveal this vote, we would be stuck and not actually, it wouldn't actually go through, right? This thing will return and will say, sorry, your vote hash does not match your actual vote. So there we go. Then we can do the same thing for vote number 2, and we can say, password 123. And 1, 2, 3. Reveal vote. OK, cool. So now we have 1 vote for choice 1 and 1 vote for choice 2. Great. So let's see. I'm curious. So the kind of a fun thing to do with this is actually stage a vote over the testnet and have a bunch of people participate. And so I'm not sure. Hopefully we have some people who have added their or who have installed MetaMask. Let's see. Let's check back. Dun, dun. Okay, so we can have a real tight race between three possible votes. So the way that this works is so if you wanted to, so this was all locally done, right? This was all locally on our JavaScript VM. But what we can do is we can actually run this and deploy it to the mainnet. So if I change it over to injected web 3, then we can call this create, and we can say instead of let's do like 300 seconds, and we can say okay. So if we can get people to vote, and if those people who have submitted their addresses, then if you win Karl Sings, then I will sing a short song for everyone. And if you vote for Karl Helps, then I will spend the rest of the time helping answer all the questions that people have. So you can choose which one. We may have choose which one you'd like to see more. And so we have 300 seconds to make this vote. So what just happened was I actually submitted a transaction to the Rinkeby testnet, and that transaction deploys this smart contract. We wait number of seconds for it to actually come through, and what I'm going to do is I'm going to copy the address of that smart contract, put it into the GitHub gist that I had created earlier, and then what you can do is you can actually apply that address and call the functions on that smart contract, from your machine. So basically, we can all like point at the same vote, because essentially you can think about all of these contracts. You have your like class, and then you're instantiating it when you deploy it. So here's the contract address. And let's go in here. And so I'm going to kind of refresh just so that I'm in the same spot that you are. Let me actually first post the thing. Ta-da. So I think it was right here. Here is our address. Okay, so that's the address of the smart contract. What you'll want to do is you want to copy that and go into your browser Solidity. Make sure that the code is the correct code. And the way that you get that code, just FYI, right, is follow this link. And this will get you loaded up with all the right code. And then you'll go to run. And you'll say @address. So the way what this just means is like, okay, we have a contract. It's already deployed at this address, and we're just pointing our browser Solidity at that contract. So let's see, pending transaction. Dun, dun. There we go. Okay, so now we can interact with our smart contract just as usual. We can say, commit a vote, reveal a vote, and once again, let's see if there are any votes yet. Oh my gosh, probably not. I would imagine not. Okay, so this contract is now live, and you can actually, send transactions yourself. Hopefully, we have someone. Is there anyone here who has a computer, who posted on the thing and got ETH and is able to send this transaction? I'm curious. Is anyone following along? Rinkeby testnet, correct, yes. Still no ETH. Oh man, I got to get you some ETH. Oh, you sent it? So the way you check your ETH, right? That's right. Should be right here. Should show up pretty instantly. Huh? Ah, okay, I see. But it should pop up in their account, right? And yeah, so he actually sent it using that multi-sig, that multi-send smart contract that we were looking at earlier, which is why, by the way, so like people say, this is how many transactions this blockchain uses, this is how many transactions that blockchain uses, but every transaction is not made equal. So you can actually send a lot of money or do a lot of things in one transaction, and so it's kind of like a weird metric, but that's how it always is. Cool. So while we're waiting for that, are there any like questions about maybe the relationship between, or any questions regarding Solidity or the kind of general stack or like where things are? Maybe too many options, right? So let's see. What is a good? So how many people here have actually made a like a dApp or made a website that talks to an Ethereum node? Okay, we got a couple. That's awesome. Is it clear so one thing that always is kind of a little bit weird is like this relationship between Web3 and Ethereum, and so like Web3, just like I don't know, the way that I would always conceptualize it is you have these Ethereum nodes and they live off in space, and you can on your machine, right, on your Web3, you're just like sending transactions and signing transactions and broadcasting them to that node. And so like a dApp, what that really means is you go to a website and you say, okay, you know, pull down this information from the blockchain. Normally dApps will have like some kind of state stored in a smart contract, and it'll like generate based on your address some kind of web view, and then you just sign transactions locally and broadcast them. And so this, MetaMask makes this super easy because you don't actually need to be running a node on your computer. Yeah, and so how many people have written a like Solidity smart contract? Maybe there are more people. Nice, there we go. What was your smart contract? Ah.
And now I have a microphone. So then they would be able to submit their hedges. The hedges would be recorded, and then later there would be transactions that would then be recorded to an array. Mm-hmm. So then over a period of time, it would keep a running total of how much money would be owed back to the person in exchange for the hedge that they put in place.
Cool.
Right. So then it was supposed to be just as a contract. You get it started. You indicate what kind of length of time you want this contract to be for, or this hedge to be for, and then it would automatically execute. It's really, really basic. I claim no sort of advanced function or any kind of good design as Lane suggested.
No, that's good. That's awesome. I mean, the current state, like this current state of these smart contracts is honestly pretty basic. But those are the kinds that are actually super useful because, like, actually creating financial tools like this, if you weren't using Ethereum, would be like impossible. You have to go through, if you want to create a derivative, you have to go through tons of regulation. This is super hard, but actually it's so easy when you're using Ethereum. And even though, yes, okay, it's 10-second transaction times, and most people won't use it, it still like unlocks a whole new like level of programming. And so this is like one example. Uniswap is one example of a smart contract that, or a dApp that was created super simply by a friend of mine, and it's actually like quite useful. So this is a decentralized exchange that allows you. So let's actually take a look at the smart contracts behind this, and there we go, Uniswap. So public smart contracts, and let's just look at uniswap.sol. Okay, great. So, so the way that this works is we have a, this is all deployed. You can actually go on this if you have, MetaMask. You can interact with this today. You can simply like buy Uni. So if you want, let's say I want to buy 150 Uni. So on the back end, what is actually happening? Well, this smart contract was created by some kind of market maker. And the market maker said, okay, I'm going to set an exchange rate. I'm going to send, like 100 ETH and 10,000 uni. And what I'm going to do is that is going to be calculated as the invariant. So let's actually look at the code, because maybe it'll be a little more revealing. So we have our Uniswap contract, and we say, OK, initialize Uniswap. So here's our invariant, right? It's the initial token quantity multiplied by the total ETH quantity. So it creates this, let's say, this could be like 1 million. And this will never change. And so when we send ETH to the smart contract, what it's going to do is it's going to add ETH to the ETH balance and then calculate, OK, what times that ETH is equal to that invariant. So if we actually look at it, we can say, OK, we have this little fee, and then we say total ETH quantity, add the actual amount of ETH. So this, by the way, is this safe math notation. So essentially, there's overflow and underflow issues with Solidity, and we kind of do this monkey patch safe math thing. But if you use Viper, which you totally should check out, you don't actually have this issue. So new total tokens. So now what we do is we calculate the new total tokens based on how much ETH we have. So here's the real calculation. So let's say we start out with 100 ETH, and we do that times 1,000 tokens. So that's 100,000, right? Now we receive 1 ETH, right? Now this invariant is at 101, which it should not change. So we actually have to reduce this to 990.1 or something like this, right? So now what that means is we've implicitly sent 10 ETH to the person who just sent the 1 ETH. So it creates this exchange rate. And so as we send more ETH, right, we're going to actually need more and more of this. The exchange rate is actually going to get worse and worse. So the first ETH we sent, we got 9.9 tokens. The second ETH, we got kind of 9.8 tokens. So this is generally how this thing works. And so we can actually see it working here. We're going to just buy uni. We put in 150 uni, which is going to cost us, what, 0.88 ETH. Send our transaction, remember the gas price. And this is, so once again, what Lane was talking about, we need better UX. Even this, right, this is pretty good, but comparatively speaking, realistically, no one's going to understand what this address thing is, right? People are going to be oh, what are these long strings of numbers? We need to make that way more user-friendly. We also can't expect everyone to switch their browser to a block explorer to see if their transactions actually got through. These things need to be included. So this, my friend sucks at UX, right? He should have included a spinner thing saying, oh, your transaction is being mined or something, or even better, do some kind of zero confirmation reaction. So essentially, what you can do is, depending on how you design your smart contract, you can actually make it so that you know that the transaction will go through using some kind of state channel. And so you can get this kind of instant finality. So the issue is, the reason why we have to wait 10 seconds for a transaction to be included, right, is because if we don't wait that period of time, we don't necessarily know that that transaction is going to be included in the main chain. So if we buy a certain amount of ETH, we don't want to update the UI saying, oh, your ETH went through, when maybe it didn't. But what you can do is you can actually make it so that the logic of your smart contract does something maybe off-chain, and you have some settlement mechanism that can settle later on. But you know that if you sign this particular transaction saying, I promise to buy this amount of uni, and you know that that will always be able to make its way onto the main chain, then you can actually instantly confirm. So it's basically like a bar tab. This is a really easy way to think about it, where you say, OK, I'm going to open up a bar tab. I'm going to say, OK, I'll give you as many drinks, instant confirmation, and then close it in one transaction later on. So anyway, we now have this transaction. We can see in our block explorer that it actually traded this uni token to our smart contract, or to our address, And if I check my balances, I can go into tokens, and I will see, boom. So I have 251 uni. So great. And the way that, by the way, you can add any number of tokens. You just like click Add Token, and you give it a contract address, and then it'll fill out the rest of the information. So this allows you, if you had GNT or Golem or whatever. So there we go. Now we have this amount of uni. And it was all in one transaction, which is super nice. Clearly, there are things that need to be worked on, though. So if we look at the actual smart contract, pretty simple. So we've got this minimum number of tokens. This allows us, this basically, so the reason why we have this minimum tokens is if we send a transaction saying, OK, I want to buy any amount of tokens for 1 ETH, for instance, then what can happen is if the market is really small, you can have miners see that transaction and say, OK, actually, you know what I'm going to do? I'm going to move the market so much that you're going to get a really unfavorable rate for your token. So you're going to get, basically, you say, I want to buy tokens for 1 ETH. The miner then buys a whole bunch of tokens, maybe 100 ETH worth of tokens, which moves the exchange rate of the tokens really, really low. And now your 1 ETH only got you like 3 tokens. So what this does, this says, OK, I'm going to, not only am I going to sign saying I want to buy I want to buy 1 ETH of tokens, it's going to be I want to buy 1 ETH of tokens with this minimum rate. So these are the kinds of things that you have to consider. You want to say like, OK, if we're talking about a financial transaction, we need to be very cognizant of what ways that miners can manipulate it or other users can manipulate these systems. And then here's a timeout. This is just saying, OK, if I sign a transaction, I can't just hold on to the transaction for a year and then publish it, because who knows if you really want those tokens after that time. So you've got this purchase number, number of purchase tokens, and require that the current time, this now variable, oopsies, require that the current time is less than the timeout. Pretty simple, and send the purchased tokens. So like super duper simple, and this is actually like a reasonable mechanism in that it actually, it's, how many lines of code? This is 162 lines of code. It doesn't have its own ICO, right? And it just kind of works. So this is, I would say, like a good example of something that anyone can build with a smart contract. And there's something to note here, that it's actually like completely trustless. So what you can do is if I showed you this code, and you were able to read it completely thoroughly, you would know that there's no way for me to kind of manipulate you to steal your money. And this means that anyone can just like write this code, post it on Reddit, and get people to use it. And this is like something that just wasn't possible before. Cool. And so Solidity is not the only programming language on Ethereum. So essentially, all of these programming languages, they compile down to what is called the EVM, right? So EVM bytecode, and those, and so Solidity has been worked on for quite some time, and it compiles down to some kind of naughty EVM code. It's not really the nicest code, and EVM code, actually, by the way, what we can take a quick look. It looks something like. There's actually a debugger, which I unfortunately didn't get to go through. Let's see. OK, well, it's basically just like assembly code. I'm popping up there. But so there's another language, Viper, which Vitalik started, which it also compiles down to the EVM. And so this right here is the simple Casper. So this is what I work on. So I'm actually, I'm an Ethereum Foundation researcher. I spend most of my time working on Casper and getting this first Casper implementation out the door. And so a key part of Casper is this smart contract. So the way that Casper actually works is, Casper. So Casper is proof of stake on Ethereum. It's kind of the next step after proof of work. Proof of work is what currently secures the Ethereum blockchain and make sure that we don't get 51% attacked, basically have anyone rewrite what the history is. So we've got Viper. It looks like Python, right? It's basically like a typed Python, which is pretty nice. And so we can go through some of the general like syntax of Viper, where you've got like asserts, and we've got it actually the way that Viper actually the Viper compiler works is it actually uses the Python compiler, so it really is valid Python, and you can still use a linter and whatnot. So we've got the ability to deposit so well, actually this maybe requires a little bit of Casper background information, so maybe I won't get into too many details regarding what Casper does, because there's a lot of material out there for that. So I would say maybe let me open this up to you guys. Please ask some questions about, it can be anything regarding, dApp development, Ethereum, smart contract writing, whatever is, you're thinking of. You got it. You know there's a question out there that is waiting to be answered. There we go.
Hi, Lane. Hey, I have some question about. I tried the tutorial before, and if you have any suggestion, if I have to train my skill about coding the smart contract, and I try to find some way to get better. If any suggestion.
Sure. So basically, we've got there are tons of Ethereum tutorials, and a lot of them definitely are pretty confusing. Of course, Karl.tech, those are two of the best. But but outside of that, a good way to get started is using truffle. So truffle is a kind of food that you can eat. Just kidding. I mean, it is delicious, delicious food. But truffle is also a tool which allows us to write these Ethereum smart contracts. It's like essentially it allows you to create a website dApp. So what it does is it has it's kind of borrows from the Ruby on Rails tradition, where you just convention over configuration kind of thing, where you just install it and get started, and you can deploy a smart contract and create a UI. So you just simply npm install, and they have actually some pretty good tutorials on writing your first dApp, right? So for instance, right here, this is probably a pretty good place to start, because not only does it give you the ability to compile and write a smart contract, but it also gives you the sense for how to hook that into your front end, and that I would say is definitely a helpful thing. Cool, great question. Oh my gosh! Oh yeah. So here's I will sing a song. Unfortunately I wish. If only there were more people with laptops. I don't know. Did anyone vote? This is the real question. But I will sing a song just because. To make you happy. Oh my God! We got a vote for choice 1. We actually did get a vote. Oh, and we got no votes for choice 2. Okay, so it's actually legitimate that I have to sing. Wow, great. Success. That's awesome. Okay, so last time I did this, I sang "Call Me Maybe," which I will attempt to do again. Just give me a moment to kind of prep, Gotta breathe. All right. I'm not a singer. I don't know what I'm doing. Okay. Oh, can we get a little clap going, Hey, I just met you, and this is crazy. So here's my number. So call me maybe. It's hard to look right at you, baby. So here's my number. Call me maybe. It's turned into my life, but you're so bad. But you're so bad, and you should know that. Well, you know, great. Oh my gosh. Well, I'm a little flabbergasted, but yeah. I don't know how to go on from that. If there are any more questions. Oh my goodness. I think we have, we have like maybe around 10 more minutes. There we go, another question. So I actually haven't, and that would be a great thing for everyone else to do, right? It's pretty easy. Like to actually create a GUI for this, just to kind of like give a general overview, is you would just write your normal kind of web front end where you just like create an input box and a button, and then literally all you would have to do is you would say maybe you would include like a You would include something like this, right? You just make it so that, okay, please, put in your vote, choose, a radio option 1, 2, and then put in a password, and then it would generate your commit, and it would say like save this information, and oh man, this is actually getting complicated. Now I realize this is why UI is so bad in Ethereum. We need better ways. So one thing that I am a fan of is actually centralized key management. I think that it's probably going to be very difficult for people to kind of get over the fact that there's this like big address thing, and I have to store this, these number of words. So it should be like, I would say that's things like Coinbase. And kind of normal, username, password combinations are probably the way to go, even in this decentralized space. And so doing some kind of commit reveal thing, you probably would want a like normal user, like a normal like a login or something like that, and then you submit your vote and you just click it, and then it hides all this kind of complexity. Maybe it even like generates a password based. Generates this kind of this password thing based on your password or something. So these are the kinds of things that it's an open area of research, and please, like UX people, help us out. Any more? Right there.
Are developing a new programming language called Viper?
Viper, yeah.
Yeah. Is there a community for that, and is there Integ? How Integ is this programming language, and is there any Redux for that?
Yeah, great question. So Viper is being actively developed, and it actually has a surprisingly big community. You'll notice that like we've got 52 issues, and they get comments on daily. We've got a bunch of pull requests from a lot of different community members, as you can see, right? So this is this programming language. It's not quite production ready in that it has not, the code base has not yet been audited. And so what we're going to do, though, we have it to a point where it's almost feature complete, right? We've got we've basically accomplished all the things that we want to, and now it's just up for an audit. So it actually, by the time this Casper contract is going to go live, I'm sure that Viper will actually be, pretty ready for production, and we can, and so I would say start messing around with it today, because even if you're, even if you, chances are, if you start writing a smart contract today, you're not going. It'll probably take, take some time to actually, get it out there. And so I think Viper is totally a good option to be like messing around with. Although I would say that it's true that the docs are not as good. So we do have some Viper documentation, and please submit pull requests. Oh, one way quick to the Ethereum Foundation's heart is contributing to all these open source projects. So remember, like there's Ethereum, this repository right here, and it's got a bunch of things that you can contribute to, including Viper being a good option. And there's also ETH research. So here's it's a nice form where you can actually like read a lot of the research topics that we're considering and say, contribute and say what you think. So I would say that these are really good places to take a look at. And so we've got some installation guides and Viper by example. Got some good examples, but it is definitely, number one, it's actually a pretty simple language, so it maybe shouldn't be the end of the world, even though the documentation is maybe not there. Any other questions? Right there.
Hi, Carl. Is there any pros or cons in the Viper language when comparing with the Solidity?
Yeah.
Like a better performance or other things?
So I actually haven't taken a look at the performance of the two languages. I would imagine that Viper would actually be more performant, just because the actual compilation result is probably significantly simpler, like the actual LLL output. Now the maybe a con would be it's less expressive than Solidity. So Viper is safe through simplicity in a lot of ways. So basically Viper constrains what you're actually able to do. One of those constraints is you'll notice that in Solidity, well, I would show an example, but so here we've got our variable definitions. And in Solidity, you can define your variables below the functions that you actually use your variables in. But in Viper, you have to make sure that everything is everything is compiled from top to bottom. And so you have to know, like, if you're using a variable, it's defined above, or there's going to be a compilation error. And there are other things like this. For instance, you can't use inline assembly. So in Solidity, one of the features is you can write this in inline assembly. But the problem with that is it kind of throws all your guarantees out the window. So once you have a little bit of inline assembly, it can be really hard to reason about what that's actually doing. And so if it mutates a memory address, then it's very hard to spot a little error that could just totally, for instance, allow the smart contract creator to withdraw all the funds from a token launch without actually issuing tokens, for instance. So essentially Viper won't let you do everything you can do in Solidity, but the trade-off there is that it's significantly safer and easier to read. You know that everything is compiled from top down, and you know that there's not going to be these crazy like inline Solidity hacks that cause problems. Ooh. Oh, inline assembly. So essentially, the way that the EVM boils down to like assembly language, which is like push, pop, add, whatever, and this inline assembly allows you to actually define like the EVM opcodes that you want to run. So if Solidity isn't expressive enough or doesn't have the opcode that you're looking for, you can just like pop that in there.
AI area. I remember last year I was in New York City and I saw some demonstration of AI called Crane AI. I don't know if you've heard of it. Basically is AI automatic generating code for some kind of programming pattern. So pretty much that's sort of computer science of the holy grail, right? You generate some code based on AI pattern, and then that guarantee the pattern of bug is controllable, meaning the merging of what you guys are doing, the modern day and the AI. Is there intersection, or you come across this kind of technology in your world?
Yeah. So AI and blockchain have an interesting relationship. First, of course, like if an AI can write our code, then our job is done. So hopefully that'll come soon, right? Then no one has to work and we can just sit. But the actual like practical today, what AI is being used for, AI the actual capabilities of these like programs are going to be enhanced significantly by the ability to have financial sovereignty. So essentially, Ethereum doesn't distinguish between a human and a robot. Right? This is a key point of Ethereum, because that means, you know, I can be sending a transaction and I can be voting on something, or my toaster can be sending a transaction, my toaster can be voting on something, right? And that also goes for that superhuman AI that was generating code, you know, that doesn't exist yet, thankfully. And so this kind of sets the stage for more powerful like AI or automated systems. And in fact, something that will happen is in this smart contract, so kind of bringing it back to the Uniswap thing, you'll notice that this exchange rate won't change unless you're buying and selling, right? So you can actually, what will happen is if the exchange rate on some other exchange kind of like drops really low and the exchange rate on this exchange is still pretty high, then people are going to certainly write a bot, and the bot is going to say, okay, check the exchange here, check the this exchange. If there is a discrepancy, let me arbitrage that. So a common pattern is that what we'll do is we'll create these these smart contracts, right? We'll define some kind of financial rules, and then people will say, oh, I don't actually need to be doing this myself. I can just have an AI trading for me, right? So that goes for, why don't, you can have an AI manage all your investments for you if you want. You can, like, the actual, like, number of areas that this affects is just like so large, and what it really does is it allows all of our programs to have this financial aspect, and that is like completely new and super exciting. Sure.
I think because of the time's issue, please save your. If you still got any questions, you can have your question directly to Karl during the break. So we are going to take a break and resume at 11:30. All right.
Great, thank you.
Hello， 开始之前，在休息之前呢，我这边几件小事情提醒，就是各位应该会注意到，进来的时候我们有调查便当嘛，对不对？所以今天其实我们会提供所有会众就是提供午餐，对，所以就是中午就是我们在这个场地里面内部用餐这样子，就各位就不用出去淋雨，然后买便当了，对，就这样，谢谢。 我还没讲，我是引导现场。好，我们请现场观众慢慢的就进入会场了。
Our next speaker, hello. Can we have our audience come in, please? Out. Okay, our next speaker is Ben from imToken. imToken is a mobile wallet solution, and they started their company May last year, and I meet their team on DevCon 2 last year. And let's welcome Ben to talk more about his project. Welcome.
Hello， 感谢主持人介绍。是这样，我们是来自大陆的团队，然后今天我也看到，基本上是台湾本地的这个以太坊社区的爱好者和开发者，所以我的演讲还是会用中文来跟大家交流。我们是第一次来台湾，但是我们在台湾已经有蛮多的用户了，小伙伴统计可能接近1万的我们的imToken 的用户在台湾地区。然后这几天在这边玩得挺开心的，然后本地以太坊社区的小伙伴招待的非常的周到，非常的热情，台湾的美食也真的非常的正宗好吃。那行，我开始今天的演讲，然后主要是今天给大家介绍一下 imToken 2.0的一些新的版本的变化，带给我们台湾小伙伴。首先，简单自我介绍一下，我是 imToken 的创始人和 CEO， 然后上面有我的联系方式，欢迎大家加我来交流。那么，什么是 imToken？imToken 它是一个以太坊的移动端的轻钱包，我们这样来定义它。我们在安卓和 iOS 都有相应的版本。那关于区块链钱包，我想大概给大家看一下它的最简的模型是怎样的。那我们说钱包其实有2层含义，一层是我们区块链的账户本身是公司要对的这样的一个体系，那么这个钱包是指管理私钥的一个容器。那么我们做的像 imToken 这样的软件呢，是指这样的一个钱包工具来帮助大家来管理它的区块链上的账户。简单来看这张图的话，就是imToken 是手机端的一款 APP， 然后帮助大家去管理它的私钥。那私钥的话，它会被加密之后存储在手机上面。当你需要使用的时候，需要用户来输入密码来授权解开私钥，然后才能去转账啊、交易啊，包括智能合约的调用和区块链这样去交互。那么这个钱包工具这个软件呢，大概就是这样一个最简单的这样一个产品的模型。钱包本身有很多类型啊，我这里给大家看到列了一下，就是有不同的安全等级，也有不同的用户体验。那左边来看是相对一些安全等级更高的一些策略，右边呢是可能大家用起来会更加易上手。更加舒服的一个体验。这里面大家比较熟悉，有硬件钱包，有软件钱包，有桌面端的，有客户端的。相对而言的话，肯定硬件钱包，因为它是用芯片来管理你的私钥，会更安全。那软件你只需要安装在手机上面就可以打开就可以用，对吧？然后冷热钱包，其实交易所他们都会有这样的安全策略。它在线呢会用热钱包来帮助大家充值跟提款，然后大额的资产呢会放在冷钱包里面。那同样，像软件钱包呢，它也会有相应的策略。那么我们也是建议大家把小额的像我们的 cash 一样的放在热钱包，但是 大额的资产是放在冷钱包，然后通过离线签名的方式去交互，这样会相对更安全。然后还有一些是多签钱包，那么它需要多个私钥共同授权才能做这个交易。然后单签的话，那会比较简单，然后一把私钥一个人直接就可以马上去跟区块链交互。然后还有在区块链跑的这个节点的角度来看呢，会有这个全节点或者轻钱包这个 SPV 的这种概念。那还有一种方式呢，就是由一个中心化的服务商来提供这个节点，那用户自身就不需要自己去跑一个区块链节点来提供服务，或者说手机上要去同步区块链数据。然后其他还有一种类型就是原生应用和 Web 端或者移动端的这个区分。那我们有桌面端的原生的 App， 也有这些像 MyEasyWallet 这样的 Web 的这个钱包。那总体而言，我觉得原生用 native 的 code 来写会相对 Web 的 JS 这一块会更安全。然后也有去中心化和中心化的区别。去中心化像 imToken 这种类型，包括像MyEasyWallet、Jax 等等，这些是去中心化，也就是说你的私钥是在你的手机上面，它不会在中心化的 server 上面。那中心化服务类似 Coinbase、BitGo 之类的，他们会帮助大家去管理这个私钥，也就是说你的这个钱包里面的资产，像类似于一个电子账户余额一样的方式，由这些中心化的这个服务商来提供这个私钥的管理。那 imToken 它在设计之初考虑了，首先我们需要以安全为重，然后同时我们要考虑普通用户他的这个使用的体验，所以我们做了这样一个安全和体验的一个取舍。它是软件钱包，然后我们也有相应的冷热钱包的策略，然后我们帮助大家去跑一个中心化的节点，那避免用户在手机上去同步数据。当然，我们也允许用户说自己去设置、自定义这个节点的这个 server。然后 imToken 它是一款原生的应用，当然我们会在交互这一层会用到一些这个 Web 的技术，类似于 React Native 来做交互。然后它是一个去中心化的，就是说大家是用 imToken 来自己管理自己的私钥，这非常重要。总体我们 1.0 做下来，我们从去年的5月份成立公司，6月份启动项目，然后到12月底正式的上线这个钱包。总体而言，大家对我们的这个产品的体验，包括我们的这个提供的这个服务还是非常满意的。我们可以看一下我们现在的一些数据。那其实经过一段时间的 beta， 真正跑起来是到2月份，然后我们的数据是从4、5月份、6月份逐渐的往上增长。那现在我们的总的全球的用户数量是32万，装机量用户数量32万，然后每个月的月活是18万左右，然后日活在5万左右。然后还有非常不错的一个数据，就是我们的7日留存率达到了35%，我相信这是再次用数据证明大家对 imToken 的一个认可。然后从设备的分布来看，就是因为我们首先第一个版本还是以简体中文为主，然后当然会有英文版本。那么我们服务的绝大部分的用户还是以中国大陆为主，占了73%。那我们也看到全球其他国家都在不断的增加这个比例，特别是台湾，它排在美国之后第3名。所以非常感谢以太坊社区的小伙伴们不断在帮我们推荐这个产品。他们跟我说，然后有人问说我现在买了以太币，买了某某 token， 说用什么钱包来管理，他们多半都会推荐用 imToken。然后移动端设备它其实会跟这个整个现在移动平台的分配还是保持一致，就是还是安卓为占主要的这个比例74%，iOS 26%。但是这里提一下，其实从安全的角度来说，我建议大家还是用 iOS 来管理自己的钱包。因为安卓其实它首先它可能比较容易被 loot， 然后也会有相应的一些安全的漏洞。那上一周我们就看到说，安卓的老版本在授权这个远程媒体管理这一块， 会有一个漏洞，就是说黑客可能抓住这漏洞，可以读到你文件系统里面的各种数据，是这样。刚才说了一些我们的这个用户数据还是表现非常不错的，但是其实我们也面临非常大的困惑，面临非常大的压力，就在于说我们的用户在不断的发生一些事故，那这事故主要集中在一个被盗和丢的这个2方面，那被网络黑客盗取的这个概率会更大一些，丢这方面主要还是用户自身对于区块链钱包这个概念不是特别清晰，他没有去备份，或者说去主动的去做相应的一个安全策略，导致他产生这个私钥丢失或者设备丢失的时候无法找回自己的这个资产。那被盗这边，其实我们看到很多用户对于安全的这个意识不是特别强，他们会用邮箱或者类似于 QQ、微信这样的网络工具来存自己的这个 key store 或者助记词。那么这些账户其实是非常脆弱的，很多的这个中心化的服务商，包括 Google 啊、雅虎啊，最近有 Uber 啊，他们的系统可能已经被黑客攻克了，所以你的这些资产非常安全等级需要非常高的这些信息，如果存在这些网络这些中心化的 server 上面，是很容易被黑客抓住机会的。然后还有一些其他方面，比如说他告诉身边的人自己的钱包的这个私钥、助记词，这个都有，也有身边人的这个坚守之道等等。还有就是去下载一些这个网上可能被污染、植入木马的一些这个安装源等等，原因很多。这一块的话，我们这边运营也是隔三差五的收到用户的邮件，所以钱包安全对于我们而言是最重要的事情。然后我们是在持续关注这个技术上去优化，去做相应的对策跟策略。但是总体而言，我们还是需要去帮助用户提高对这个区块链钱包的一个认知。所以这2天有很多我们的用户在问说我们那个风险测评这个系统是怎么一回事情，然后突然有这个东西。其实这个就是当我们越来越多的这个普通用户加入到区块链，然后开始使用这个钱包的时候，他们是没有这方面的观念跟意识的。所以我们是想说，你要安全的去管理你的资产，而且是这个是一种去中心化的方式。那你首先要有对这方面的概念的了解，所以我们加了这个测试题，用户需要对它进行一个学习了解之后，能够对这些关键点掌握了之后才开始用，那避免未来产生这个非常大的这个事故。同时，我们团队运营方面也在做区块链知识、钱包安全的一些知识普及。imToken 在不断的往前演进，那主要是这2方面。刚才提到，一个是技术方面，我们不断的去提升我们系统的安全等级，然后去提升我们的产品的这个用户体验等等。然后另外一方面是对用户的这个教育，主要还是要提高他们这个意识、思维，改变他们的这个传统的这个中心化账户的这个保管的这个思维习惯，还有需要提高他们对现在非常多的这个骗局 （scam、phishing） 这些鉴别力。好，那前面是一些背景介绍，然后接下来是跟大家介绍一下我们的新产品2.0。2.0我们是从8月份开始计划投入研发，然后经历了3个多月的开发，现在是处于一个 alpha 的状态。里面的这个变化跟改进非常的多，上百项。那么今天我主要重点讲3块，也是大家应该比较关心的这3块。第一，我们将支持多链。原来第一个版本我们只是以太坊的钱包，只能管理以太坊上面的 ERC20 tokens。这个版本我们从用户的角度来看，用户不只是说他有以太坊数资产，还会有比特币，还有其他链上的资产。所以我们重新做了新的系统架构，来支持到更多的链。那么首先第一版会上去的是比特币，将来我们还会支持更多的其他的这个区块链。 所以最终想达到一个目标，就是让普通用户不需要去了解他持有的数位资产是在哪条区块链上面，他只需要关心说，我怎么用它，或者我怎么投资，我持有的是什么。然后第二块是 imToken 想去集成去中心化交易所。那么有看到以太坊社区，他们有很多的创业公司在借助以太坊的智能合约来开发去中心化的这个交易系统，我们把它叫做 DEX Protocol。那我们也做了这些协议的一些调研和 POC，然后 imToken 2.0的话是希望跟这些协议去合作，然后在他们之上去构建去中心化的这个交易，提供给我们的用户。那主要我觉得非常重要的一点就是去中心化交易所会提供给我们去信任和更安全的这个交易的环境。这里中心化交易所的弊端和诟病，我这里就不再多说。那么主要从产品的形态来说，我们会有2种模式，一个是闪兑模式，它非常像一个 ATM 机，你需要兑换某一个币种，你可能只需要把这个币打出去，然后另外一个币就收到了，然后就在你的钱包里面了。这是一个非常便利、快速的一个闪兑模式。还有一种是类似于传统交易所的体验的挂单交易的模式。一会儿我们可以看一下我们的 demo。然后在这个中心化协议之上，我们是想把各种角色都把它们融合进来。我刚才说了，它是基于智能合约，它不需要中心点，不需要有一个第三方，它是基于智能合约的原子的交换。对，就这些角色，比如像我们普通大多数用户可能作为 trader， 对吧？作为交易者，然后这个市场会有 market maker、taker， 还有可能需要有撮合的机制、撮合引擎，还有跨期套利的角色的，还有像 Kyber 的话，它引入了这个储备金管理这个基金管理者的这样一个角色。那这些角色都可以借助我们提供的这个 DEX 服务平台来参与进来。那我这里有一张架构图，这是我们的一个设计。可以看到，就是 Protocol 这一层，像 0x、Kyber、ASWeb， 包括 Loopring， 它们是基于区块链的智能合约去构建去中心化的交易的协议。那 imToken 是想在这些协议之上，我们去构建一个 Gateway Service， 在这个 Service 之上，我们去打造我们提供给用户的 UI， 然后第三方的 DApp 开发者，他们也可以借助我们的这个 Get Service API 来构建各种各样的金融工具、金融产品。这是我们的一个关于 DEX 的这样一个架构设计。然后我们再来看看第3块。DApp Browser， DApp 我们之前就有imToken 自身团队也开发了2款，就是一款叫 ENS， 帮助大家去注册以太坊域名的，还有一款是 ICO， 方便大家非常便利的去参加这个各种优质的 ICO 项目。那其实社区里面，大家看到这个 DApp 的这个词汇比较多，但实际上，真正能落地上线的还比较少。但我们这次 DevConf 3，我们也看到像 Maker、Augur 他们，包括 Digix， 他们已经有计划在今年年底会上线他们的这个正式版。所以我们可以期待的是，在接下来的半年、1年的这个生态的一个变化发展的话，会越来越多的这个 DApp 加入进来，所以我们这里做了一个浏览器，方便大家去直接去跟这些第三方的 DApp 交互，然后不管是在我们的 App 内部还是跨应用之间，都可以完成这样的一个你的钱包和它系统之间这个交互。同时，我们也会让大家可以去访问一个 URL 或者 ENS 的方式去找到它。然后这边当然会有一些小的其他的一些 feature， 比如说这个 DApp 它会有一些通知过来，那你在钱包这边就会收到相应的一些操作，比如转账的通知，比如参加ICO这个结果的通知等等。 然后下面会有这些 App 的聚合的这个信息流在下方。除了我们把这个 DApp 加入到 imToken， 让用户可以一个浏览器的方式跟它去交互之外，我们还提供我们的 DApp SDK。主要是几方面，一个是我们想把标准的这个 Web3 JS 注入到第三方 DApp， 方便他们去管理以太坊的这个账户。另外的话，我们会允许第三方开发者来请求 imToken 用户的一些上下文，比如说他的这个 user profile。当然，未来可能会有 KYC 等等，包括地址本这些信息。还有一块，大部分的 DApp 还是以 Web 为主。那么 imToken 是一个原生应用，我们可以把一些原生的这个接口，比如像 camera， 然后 GPS， 还有一些这个动画的这个感应器，都开放给我们的 DApp 的开发者去利用起来，打造更好的体验、更有创新力的这个产品提供给用户。那 DApp 的 SDK 我们现在也还在这个内部的这个测试之中，后面我们正式发布了之后，DApp 的开发者可以加入进来，一起来创建非常有意思的这些 DApp。刚才大概过了我们 2.0 的3大新的 feature， 然后现在是想给大家做一下我们的这个2.0的演示，让大家感受一下这个 look and feel 是怎样的。我让同事帮我举麦克，然后我这边是连上我自己的手机，这边屏幕上显示其实就我的这个台 iPhone 上面装了2个 imToken， 左边的是原来 1.0 版本，然后右边的是我们新的这个产品。然后打开之后，我们可以看到，主要的信息架构跟原来不会有太大的变化，还是原来的几个大家熟悉的导航。第一个 tab 是围绕着钱包的，第2块是我们的市场行情这一块，第3就我刚才提到的这个 DApp 浏览器频道，然后这边是跟账户相关的一些设置的页面。这里可以看到我们这边已经支持了比特币，然后去创建比特币的话，整个交互体验跟原来以太坊的没有太大的变化。我们可以看一下，我这边创建一个新的比特币地址。我这边为了演示方便，就简单输一个密码，大家不要去 follow 这个行为哈。可以看到，就是我们为了保障大家用户安全，还是在创建的时候要求大家去马上做一次这个助记词的备份。那我这里先跳过，可以看到这个比特币的这个账号已经生成了，然后这边我们签到一个有交易记录的 App 看一下。这里是这个钱包的这个资产的详情页面，你在这边可以看到你的这些交易记录，然后这个是交易的详情。当然，你可以去 Blockchain Explorer 上面看更多的这些资料。然后这边是一个收款码，这些跟 1.0 没有太大的变化。然后这个是转账界面，这里我先不做这个演示了。OK， 我们回到大家熟悉的以太坊的这个钱包，然后我这边想给大家看一下，就是关于 DEX 交易这一块。首先是闪兑，我们是基于 0x 做了一个 POC。0x 的话，它首先是需要把这个 ETH 换成一个 WETH， 就是变成一个 ERC20 的 token， 然后它才能借助智能合约来做这个撮合。所以我们这边先把我钱包里面的一个 ETH 换成 WETH， 我们也借助这个来完成。好像有点卡住哈。 这里的话，它其实是借助一个智能合约完成一个以太币锁定到智能合约，由这个智能合约发行出 WETH， 变成一个 ERC20 的这个 token。然后，当我们有了这个 WETH 之后的话，我们就可以跟基于这个 ZEX 也是一样，就是说去完成另外一个 token 的这个转换。刚才是我把一笔这个交易发到这个智能合约上面，可以看到我们的通知已经收到了，就是转账成功了。所以这边我们如果去刷新余额，可以看到它现在变成 1.5 了，也就是说 ETH 已经换成 WETH 了。那么这时候我就可以用 WETH 去换一个另外的 token， 比如说 SMT。那我想换一个500，这里会有相应的这个交易所的报价的汇率，它自动会算好，你可以换到多少的 SMT， 我们换500。所以这里就是把 WETH 做一个授权，因为 ZEX 它是 off chain 的一个 order， 这里其实是用你的钱包去产生一个 order， 用你的私钥做了签名，就表示说你有这个意向，你作为一个 maker， 生成了一个 order， 你有意向说我要去做这个转换，然后对手方 taker 他可能看到这个 order 之后，他可以来 fill 你的 order， 拿了你这个离线的刚才签名之后的 order 放到区块链上面去完成这个成交。那这里我们是后台做一些这个我们这个技术人员在做一些处理，就是说我们有对手方他作为 taker 把刚才我发的这笔 order 去吃单吃掉。那如果顺利的话，我们会在这边收到我们相应的 SNT 和这个扣款 WETH。这个是后面会有很多角色，我刚才介绍，它会有这个 trader、market maker， 对，各种角色可以参与进来。那我今天主要还是演示这个流程它是怎么工作的，对。OK， 它这边交易记录已经显示我刚才的500的 SNT 已经兑换成功了，所以我们这边应该是会收到，就刚才我用0.049换到的500的 SNT， 然后我的 WETH 0.0425已经被扣款了，是这样，所以它是在钱包里面借助去中心化的协议完成了这个即时的兑换，非常快。大概就在一个区块的这个时间，几十秒就完成了这样的兑换，非常方便。除了这个闪兑之外，我们也提供类似于交易所的这种交互体验，就是你可以去设置相应的价格来挂单。这里的话，因为这个流程会比较慢，我就给大家解释一下，然后不做演示了，时间有限。那这里要强调一下，就是因为 ZEX 还是会有一些预先设置，就是说你首先要把这个 token 先解锁，就是 approve 你的余额可以被智能合约来扣款。所以在这边的话，你在操作之前，你首先要把这个 SNT 或者 WETH 先解锁，那么智能合约才能来帮你做这个 atomic 的 swap。那这里挂单就跟交易所是一样的，就是说你去买以什么样的价格，然后买多少，然后你这边会有预览，然后确认之后跟刚才交互是一样的，就是说你可以去发一笔交易，然后签一个名，这个 order 就会挂到 relayer， 就ZEX 有个 relayer 的角色就是维护这个 order book。那下面看到的这个市场深度的话，就是 order book， 有买卖双方的挂的订单。然后你如果是看到这个 order book 里有一笔是你有意想要去交易的对手方，那你可以直接去点这个 order， 然后你成为一个 taker 去 fill 这个 order， 然后这个时候的话是及时的完成了一个刚才跟闪兑类似的，把这个 order 在区块链智能合约里面去完成这个交易。 然后其他的话就是常规的，比如说你挂了单，我在这边会看到这个我的尾单，然后数量的话，它有可能因为对手方的数量不一定是你要交易的那个数量，所以它有部分成交看到，然后我也可以撤销掉，然后这边会有你所有的这个SMT 对 WETH 的这个交易历史记录。OK， 这一块是关于 DEX 的一些介绍，我们还有大概1分钟时间，我们看一下这个 DApp 浏览器这一块。那这一块的话，就是变化跟 1.0 不是特别大，最重要的还是在于 SDK 的，就是赋予我们第三方开发者更多的这个接口，更多的上下文的这些信息提供。那我们也在跟一些这个社区的合作方合作，把他们的 DApp 集成到我们 imToken 里面来。那这里的话。1.0的用户会比较熟悉的就是2个我们自己开发的 ICO 和 ENS 的 DApp， 这里稍微看一下，就是大家可以很方便的去参加到一个 ICO 的项目，不用去关心它的智能合约、它的参数设置，你只要关心说我愿意多少的 ETH 去参加，相应的兑换的比例的这个 token 就回到你的钱包。那 ENS 这边的话是以太坊的基础设施，那么我们也做了这样一个移动端的优化，方便大家去在钱包里面去完成一个 ENS 的竞拍。拿到了之后，竞拍获得之后，你可以去设置这个 ENS， 那你就可以在转账的时候去使用它。我不知道大家有没有发现这个 feature 哈，就可以看一下。我这边之前已经有注册了一个 Consent Labs， 我们公司的这个 ETH 的域名，所以可以看到这边其实它已经映射到一个以太坊的这个地址，所以你转账的时候不需要去输那个非常繁琐的那个地址，只需要用域名就可以了。OK， 就是这3块就是我们刚才提到的，一个是我们支持了比特币这条新链，当然我们的架构允许我们可以支持更多的这个区块链。第2块就是我们尝试把现在比较热的去中心化协议集成到 imToken， 然后同时还建立一个 Gate Service 给到开发者去构建去发挥想象力，去创建各种各样的金融工具。然后第3块，我们提供 DApp 的 SDK， 让开发者可以去借助移动端的这个一些这个接口，可以开发出非常好玩的一些应用。这里面我们可以看到像预测市场啊、游戏啊，然后这个各类金融产品都会涌现在这个频道。所以将来大家可能这个你的钱包里面的 token 不只是一个资产而已，它可以有真实的一些应用场景、具体的一些应用案例。我们回到这里。
我们谢谢何斌跟我们分享。
谢谢大家。
谢谢。Let's welcome our sponsor, Yvonne from BitLX, to talk on his project or her project. Let's welcome Yvonne.
Hello， 各位好，我是Yvonne，先跟大家分享一个我昨天看到一个很有趣的一个新闻，就是大概在澳洲的新闻吧。他说比特币挖矿这件事情在全世界已经耗损的电力已经超过全世界159个国家的总和的耗费能源，所以你我在座的各位，我们所有的人都是这个能源很重要的消耗者。但是也是台湾电力公司很重要的客户，所以我们就进入正题，就是币托 EX。 那首先感谢这个台北 Ethereum Meetup 的邀请来参加这个会议。那我也很高兴来做个简短的介绍。那我们台北 Ethereum 我们那个币托呢，在台湾创建4年，4年的时间呢，我们大概有20万的客户。那这20万的客户其实有当地的台湾人居多，但还有少部分的就是在台湾的外国人。那今年呢，到2017年，我们币托正式成为一个控股公司。那这个公司呢，我们有一些在海外的分公司，像新加坡、日本，或是印度，或是上海。那以前我们就很 focus 在那个区块链的应用。比如说像那个大数据交易，或者是安全风控系统方面的一些知识。所以到2016年的时候，其实我们曾经在这个台湾金融研究院发表了，就是台湾的金融那个 digital currency 的那个雏形。然后也很荣幸的后来被他们邀请成为就是全世界成为第5大的钱包公司。那我们在我们的 user 结构里面，其实以前有很大一块是在 gameplay 的上面，因为这些小朋友，他们年轻人，他们可能没有信用卡，他没有办法在国外买卖任何的比特币的比如说他的电玩的 credit 啊，或者是游戏点数，所以他们需要用比特币来做交换。那到后来呢，现在我们有很大一块呢是在这个投资者身上，因为投资者呢因为大家已经不放弃黄金或者是基金的一些投资买卖，他们认为比特币是一个长期的风控比较好的一个投资标的物，所以我们也很大在投资者。再有一块呢，我们很特别的这个要特别介绍是外劳方面。外劳其实他们因为每个月在台湾，他需要汇一些钱回他的家，可是他没有银行账号，所以他需要利用比特币来做他的这个中间的转汇。那比特币的特性大家也知道，因为它快，而且它不需要太多手续费，而且他知道它很安全，所以他们会选择台湾来，都会选择我们币托来作为这个主要的这个交易平台。那我们很有名的是，因为我们跟全家有合作，所以我们的比特币其实可以在所有的3000家以上的这个便利商店很容易的被取得。那他们可以在我们的全家的那个官网等于说我们在 FamiPo 上直接购买比特币。或者是在我们网页上面呢，其实也可以做全家 coupon 券的抵换，所以我们当下就会报价说，像你这个可以说，我可以多少比特币转换成多少的这个中杯美式券或是冰淇淋这样子，那 user 他们就会把这个等于比特币实体化的意思，这样。那我们怎么样做到说我们在跟全家合作上？因为全家这么多店，但比特币其实交易我们需要很多的这个安全机制，不然我们可能会被骇客入侵或什么的。所以我们现在呢就成立一套风控系统。那这个风控系统其实它就是每一个点其实它都是一个所谓它的节点。那我们如果特殊交易或者是异常的这个转账的时候，我们就会发现，那我们就可以结合我们的 Google Map。之后，然后我们就可以画出哪一个区域是现在正在被异常交易，然后可能会有一些或者是骇客，或者是不太，比如说可能是店员，他可能我偷偷的换一些比特币，可是他其实是他做假账，那这也有可能。所以我们做这个全家这个风控系统其实是非常好，就会及时通知这样。那另外一个比较好玩的是，我们做这个实体的这个 debit card。那有些旅行的人呢，他可以去国外，他不需要运用太多的旅资或者是带现金，他带这 debit card， 他只要他可以存入这个比特币，然后到当地之后就换成当地的法币，就把它当成一个旅行卡来使用。这样，那今年的2017年呢，其实我们很高兴在年底呢会跟大家推出一个比特币的交易所。那这个交易所呢，它到时候可能会支援就是多种的 cryptocurrency 跟这个多元的法币。那比较重要的是，它也它的安全呢，我们跟这个世界顶级的骇客专家有合作，所以大家可以放心这个部分。那这是我们大家一些媒体报道。那这个人大家很认识，是我们的 Titan CEO。那他一直认为说，在台湾呢，民众其实不需要银行，是需要的是金融服务，这是他的一个理念啦。所以他做任何的这个应用，他都是以人为出发点，然后让大家来更了解这个 FinTech 这件事情。 然后这有一些大数字，就是我们现在这是台湾第1名市占率的钱包，然后全球是第5名的钱包。那也被选为这个 APEC 地区的 Payment Solution 第10名内的这个殊荣啦。然后我们全台湾大概20万以上的用户，这样，所以就是跟大家分享币托像目前的一些进展，跟希望大家以后多多支持，谢谢。
接下来我们请精炼科技来跟我们分享。
不好意思，我自己先开场一下好了，因为我用的是新的 MacBook Air， 那你也知道它其实接头全部换成 Type C 了，就遇到这个问题，所以不好意思，请大家等一下。我有，这边我顺一点。然后新的 MacBook Air 它连 USB 的头也都没了，所以其实非常的麻烦。然后我继续讲一下，我 give up 了。好的，不好意思，耽误大家一些吃饭时间哦。那大家好，我是那个 Well 的 Alex。那 今天我一开始要跟谢谢一下那个台北 Ethereum 去举办这个活动，让我们有在不同领域的研究者能够做一个分享。那我知道大家其实应该都很饿，包括我也是，因为我早餐还没吃，所以我尽快用5分钟的时间，然后把我们的这个 project 做一个简单的介绍。OK， 那在我们 talk about whale 之前呢，其实我给大家希望大家有一个不一样的想法哦，就是大家就可以去想一下 ，Is blockchain ecosystem healthy today？ 但我知道这是一个非常大的问题，因为其实这个层面，我们如果从不同层面去思考，它都有不同的答案跟不同的那个想象空间。所以呢，我其实大概去勾勒一个这个整个 blockchain 的 ecosystem， 那我大概把它分成3大块。那它其实的组成的，包括由下到上呢，其实是有那个 infrastructure layer。那其他2-3层呢是cryptocurrency net， 就是处理在那个虚拟货币 exchange 这一块的 network layer， 还有就是应用层。那应用层它非常的广大，不管是 economy、marketing 跟 IoT、AI、supply chain， 其实它非常的大。那如果我们拆解这整个 ecosystem 来看啊，其实我们可以发现一个现象哦，就是大家可以注意一下最左边的部分，在 infrastructure layer 这一层哦。那这一层其实我们知道说它非常的重要，因为它其实就是在支撑整个生态系的发展。然后因为有 mining 这个动作呢，有 computing power 这件事情呢，然后去支撑让整个生态系能够更健全的运作这样。所以如果说从这个 ecosystem 来看的话，我们其实可以简单的说，就是底层的设施呢，措施的确去 support 整个生态系的发展。但是从这边来看的话，其实这个生态系其实目前现实来发展的话，其实有一些问题的。那我们这边尝试的去找出一些问题，那大概可以分为下面几项啊。那第一个就是大部分的 cryptocurrency mining 呢，它其实集中在一些特定的公司。那这个其实我相信大家其实都蛮清楚，一直就是在那个 China 的部分。那如果说我们再仔细去看这个趋势的话呢，其实我们会知道说，在整个上游产业，就在整个 blockchain mining 这个产业呢，它其实变得更加的集中跟垄断。那说实在的，如果说我们去思考说整个区块链这个行业跟这个架构的核心，其实它是跟整个行业的那个精神是有抵触的。所以，如果我们去回到上章我提的这个，我们看到这个 ecosystem， 我们其实可以去想说 ，OK， 其实在整个在上游产业这一块，它其实如果说集中在某些特定人士上面的话，它是变得比较不是那么公开透明的。那这个部分呢，其实也是我们今天在这边想要提供给大家不一样的想象的解法，因为我相信在场蛮多人都是从软体做出发，那其实我们这边呢是提供一个硬体的方向，去给大家不一样想象空间。OK， 所以会有出现。那我们希望能够透过硬体的那个solution呢，能够让整个生态系能够再变得更健康的发展。OK， 那我这边简单讲一下我们想做什么。那第一个就是我们想要去改变一下这个现况啊，然后去让每个人都有权利跟能力呢，去 contribute 他的这个computing power 的能力啊。那第二个，我们希望让整个不同的这个 blockchain system 的 builder 呢，能够去我们去协助他们去发展它的客制化的 IC。然后能够让去maintain它的那个私有链的运作。那第三个就是我们当然我们也是，因为我们本身是一个软硬整合的团队，那我们也会去create 一个破坏式的 business model。那这边我们其实就是我们会透过我们会利用一个类似生产跟那个销售那个联动的一个机制，去让整个在运作的时候能够有个更公开、更透明的空间。对，那最后一个就是这不好意思是字跑掉。那其实就是我们会提供一个 totally 的那个 hardware 跟 software integrated 的 solution for 整个 IoT 的这个应用。OK， 那当然大家可能会好奇说，为什么我们会有这个想法？那基本上像包括我自己在内，那还有像我们在场的那个另外一位那个就是我们的 founder Karl， 他本身在那边。那我们其实都是 hardware background， 我们在台湾。那其实大家也非常清楚，台湾在硬体产业这一块，不管是在半导体，不管是在 ICT 产业，其实拥有非常庞大的资源跟能量。那我们的确是从这个角度去做出发点，然后结合了我们的软体的人才，我们软体的专家。那我们希望能够为这个产业呢带来出一些不一样的火花跟激荡跟想法。OK， 所以这是我的 sum up。我简单的说 ，software is blockchain's future。But blockchain's future is hardware, and the future starts today. And thank you for coming. Enjoy this event, and thank you. We are well.
OK， 好，那到现在结束为止呢，那就是我们上午议程就结束了哈。那待会中午我们休息时间是到1点半，对，然后现在12点20分，大概1个小时的休息时间。刚刚讲过，我们现场有帮所有会众都准备就是午餐，好，所以待会呢就是请大家就是从这边出去，然后左转，然后排成一列，那就是领完便当之后呢，那我们用餐地点其实没有限制啊，但我们是希望大家尽量就是留在会场内部用餐，对，因为外面其实会没有什么用餐的空间，这样子。好，那就现在大家可以开始移动了，对。我们排成一列，在外面排成一列，那请外面的工作人员协助引导会众领便当，对。